Testing 1, 2, 3.
Hi. Yeah.
All right, so let's begin today's lesson. Okay, today we're going over slope formula. Which is super important because you see it all over the place. You see this in Algebra 1, 2, pre-calculus, calculus, and beyond. It's a fundamental concept in both math and physics and any kind of engineering field. Actually, slope comes up literally everywhere, like statistics, all the sciences. So like anything that's science related, even the social sciences like sociology, economics, psychology, they in their advanced levels they study statistics, and anything having to do with statistics actually has a lot of slope involved as well. So you'll be surprised how often the concept of slope comes up. Okay, so this is a line to demonstrate slope. So slope represents steepness of a line. Okay, in other words, the angle relative to, I guess, the horizontal plane, how great the angle is. So if a line, so here's our typical line right here. A steeper slope would be a line like that. Well, that's a poor example. So again, steepness of a line. So if I had an angle that, again, imagine this is a straight line instead of the squiggly line we have here. This would be a line with greater slope, with a bigger slope, because it's much steeper. You see how it's more angled up?
Yeah.
Yeah, so it has higher slope, bigger slope, larger slope. a line instead that looks like this compared to this slope, the slope of that line, the slope of this line would be lesser or smaller.
Yeah.
Yeah. Also, we always identify the sign, in other words, the positive or negative of a slope, going from left to right. So if the line is going up as you go from left to right, so this is the x-axis, it's the y-axis, we say that this line has a positive slope. If instead the line was angled down as you moved from left to right, in other words, a line that looks like that, we say that this line has a negative slope. Okay?
Yeah.
Okay. The other way to see things, so the slope measures the steepness of a line. The other way to look at it is as the rate of change. How fast does y change? So how fast does y change as x changes? Okay. That will tell you the rate of change. And the typical way they define slope in any math class is, so the slope is denoted usually with m, the constant m. So in a slope intercept form of a line looks like this: y equals mx plus b, where b is the y intercept and x is your x, y is your y, and then m will be your slope. Okay, m is always, usually, not always, denoted as m in formulas like this, but that's your slope intercept form. So m is usually described this way. So it's described as delta y over delta x. This triangle means delta. It means delta is just another word for change. So change in y over change in x. And the popular way to describe it is rise over run. And that's how I think of it, is rise over run. Okay, how much does, when you look at a graph of a line, I keep repeating this, but how much is it changing in the y direction, and how much is it changing in the x direction? Okay, so if you were to pick 2 points, you could identify the slope that way. Any 2 points. How much is it changing in the y direction, and how much is it changing in the x direction? Okay.
Yeah.
So we've already went over this. Slopes can be positive or negative. How can we tell from a graph? If it goes down, if the line is angling down, it's negative. If it's going up, it's positive. So there's 2 ways to find the slope of a line. First way is to do it graphically, and the second way is to do it formulaic wise. So graphically, you would do it using a table, like we did in our last lesson. We have our table of x, y's, and so here we have a table, and it says determine the slope of the line graphically. Pick any 2 points on the line and find the change in y over the change in x. So what is that, 0, 4? Okay, let's actually, where should I do it? Let's do it here. Oh, that's not good. me try again. So we would do 0, 4. It's right there. The second ordered pair is -2 and -2. And then we have -3 and -5. That would be somewhere over here. And then for the last one, we have -1 and 1. So -1 and 1. Connect all the points. And pick any two points in the line. It doesn't have, so it can be two close points or two far points. It doesn't matter. I'll pick this one and ask myself, what's the rise over run? So what's the rise? I'm going to pick, so Maddie, I'm looking at this one. I'm looking at this point right here. What's the rise, change in rise from here to here?
3.
3. And then what's the run from here to here?
1.
1. So it would be, so the rise.
So it's 3 over 1, which is 3.
Yeah. So the slope would be 3.
Okay.
Okay. Okay. So here's an example that I want you to try. Go ahead and do it and let me know when you're done. Are you done?
Yeah, I'm done.
Okay. So the rise, it's first off, you can tell that it's a negative slope because it's the line is going down as you move from left to right. So it's going to be negative no matter what. And the rise is going to be 1, 2, 3. And the run is what? The same thing as the last one.
1.
Yeah. So it's going to be -3. Okay. So that's how you do it graphically. The other way is to do it, use the formula. Okay. So this is a precise formula for a slope. I know I said before we said delta y over delta x, and we said rise over run, but it's a very specific formula. So given 2 points, this is point 1, and this is point 2. Okay, and these things are called subscripts. It's to differentiate between the 2 points. So the first point, the subscripts are both 1, and for the second point, the subscripts are 2. Okay, so you have xy for point 1 and then xy for point 2. So given any 2 points on a line, all you have to do is follow this formula. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay?
Yeah.
And the thing with this is you have to be, again, consistent, like with other formulas. So if you start off with this point 2, then you have to stick with the order. So you're doing y sub 2 minus y sub 1, and then over, you would, for the denominator, you would start with this as well. So x sub 2 minus x sub 1. If you had started with this point instead, point 1, you would flip it. So it would be y sub 1 minus y sub 2 over x sub 1 minus x sub 2.
Yes.
Okay, so this one, find the slope of the line that passes through the given points. So all you have to do is use the formula. And again, if you start with this one, you have to stay consistent. So you could start with either one, with this point or this point. Either one will give you the correct slope. So following the formula, we do the change in y, so 2 minus 7, and then change in x, 5 minus 4. 2 minus 7 is negative 5. 5 minus 4 is 1. And we end up with a slope of negative 5.
Yeah.
Okay, all right. Your turn. Go ahead and find the slope of the line that passes through the given points and let me know when you're done.
I'm done.
Okay, what's the slope?
Negative 10.
So let's see. 7 minus negative 3 over 1 minus 2. We have a negative negative, so that's positive. 7 plus 10 is 10. 1 minus 2 is negative 1, and so we end up with a slope of negative 10. Good. All right, next one. Go ahead and do this one and let me know when you're done.
I'm done.
Okay, what did you get for the slope?
Negative 2 over 3.
All right, let's see. So 4 minus 2, 3 minus 6. It's going to give us 2 over negative 3, or negative 2/3. Good. All right, the last concept we need to be familiar with is the idea of horizontal and vertical slopes. In other words, given a coordinate plane, what are the slopes of lines that are completely vertical, like that? And what are the slopes of lines that are completely horizontal, like that?
Yeah.
Okay. So horizontal lines are going to be described by y equals something. Anytime you get a y, just y by itself, y equals something, that's a horizontal line. It's telling you to go to the number that y equals. So in this case, it's y equals 3. Okay. And then just draw a horizontal line. Okay. And horizontal lines have slopes of 0. This is a kind of an important distinction versus a vertical line. So here's a vertical line, x equals 3. So you would go to x, where x equals 3, and you would draw a vertical line A vertical line has an undefined slope. Okay, it doesn't have. There is no undefined slope for it at all. Okay, so whenever you're asked, what is it? What is the slope of vertical line? You want to answer as undefined. It's not zero. It's just undefined. Okay, because
Yeah.
you end up with this situation where you're dividing by zero. Okay, remember you can't divide by zero. Okay, so there's this thing change. This vertical line changes up and down, but there's no change in x. So you end up with, you can pick any 2 points, but the denominator will end up becoming zero. That's why it's undefined. Okay,
Yep.
so that's it for today. Your homework. Wait. You already.
Yeah, I already did the homework.
Okay. So then,
I usually just do it like I do like ones ahead of it though.
okay. Um. All right, that's fine. So tomorrow we'll go over. Sorry, this thing right here. Forms of a line. Would you rather do
Okay,
it tomorrow or today? Because we can do it today as well.
tomorrow.
Tomorrow? Okay. Yeah, so tomorrow we'll go over forms of a line, and good job.
Okay, bye.
Bye bye.